Math 3, let's take a look at these, evaluating these logarithms. So we want to put the expressions in numerical order from smallest to largest, okay? So, question 1, 2, we're separating them, right? And then we're going to put them in that numerical order. So we'll just write them here from smallest to largest, okay? So the first step, remember, is realizing that we need to change these to exponents to help us understand a little better. Remember, the way we do it is like this. So our base here of the exponent and the base of the log are the same place. Okay, the input for the exponential becomes the output for the log, and the input of the log is the output for the exponential. Okay, so when I look at a, we kind of think we just have these equal to something. So 2 to what power would equal 32? Okay, 7 to what power equals 343? 35 to what power equals 1? And 15 to what power equals 225? And finally, 11 to what power equals 11 for the first one. So, if we look at this, the easiest thing to do is start with some of these more simple ones. Okay, that one's probably really simple, right? It's got to equal 1. Okay, anything to what power gives us 1? That's got to be 0. So that one equals 0. Now, 15 to get to 225, well, 15 times 15 is 225. So that one's squared. Okay, 7 squared is 49, times that again by 7, so 7 cubed will give us 343. And if you weren't sure about these, you could just use a calculator. Go 7 to the first is 7, 7 squared is 49, 7 cubed is 343 until you get to that answer. Okay, for 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so to the 5th. So the smallest obviously is going to be C, so it goes C, then E, then D, then B, then A. Smallest to largest. Okay? Alright, so that's pretty much what we're doing here. So if I look at 2, we have 3 to what power equals 81, 5 to what power equals 125, 8 to what power equals 8, that's an easy one, that's 1, 4 to what power equals 1, that's another easy one, that's 0. Log, now remember, if we don't write the number down there, it's a base 10. So that would actually be 10 to what power equals 100. Well, 10 times 10, or 10 squared, is 100. Okay. 5 times 5 is 25. Times by 5 again, it's 125, so this would be 3. And 3, you actually have to get to 4, 3 to the 4th, to equal 81. So we'd go C again. Oh, actually D, sorry. So we'd go D, then C, then E, then B, then A. Okay? And we go to the next one. Okay? So 7 to what power equals 45? 3 to what power equals 12? 4 to what power equals 12? 3 to what power equals 30? And x to what power equals x? Well, this first one should be easy. That's definitely 1 to make it the same. Now it's the others that are going to be trickier, right? Okay, so let's talk about those ones. Going to need some more space. So 7 to what power equals 45? It was 1. 3 to what power is 12? 4 to what power is 12? And 3 to what power is 30? Well, 7 to the first is 7. 7 squared is 49. 45 fits right in here, pretty close to 49. Okay, so if I had a calculator, I would just probably go 7 to like 1.9 or 1.8, something like that. okay, till I could get it to equaling 45, okay? But we know it's between 1 and 2. Now, 3 to what power equals 12? Well, 3 squared is 9. 3 to the 4th, or 3rd, is 27. So this one is between 2 and 3. Okay. 4 to what power is 12? Well, 4 to the 1st is 4. 4 squared is 16. 12 is in the middle here. Okay. So those two are between 1 and 2. This one's between 2 and 3. 3 cubed is 27. 3 to the 4th is 81. So what we'd need is a calculator to help us figure this out. Okay, we're just going to have to kind of play around. Basically, we've got decimals that we're going to have to deal with, okay? But 45 is closer to 49, so I'm going to try a higher number. So 7 to the 1.9 is about 40. So we know it's bigger than 1.9. 1.95 is about 44. So 7 to the 1.96 is about 45. So 1.96. Okay. Oh, I guess we do know that E is going to be the smallest, don't we? Okay. Then we do 3. So 3 to the... Now 12 is probably closer to 9, so let's try 2.2. It's 11.2, so 3 to the 2.3. That's 12.5. So 3 to the 2.25. Probably a little bit higher. 3 to the 2.27. That looks pretty good. So 3 to the 2.27 would equal pretty close to 12. Okay. Now 4. That 12 is kind of in between, so let's try 4 to the 1.5. That gives us 8, actually. Interesting. 4 to the 1.75. That's 11. So 4 to the 1.8, and that's about 12. Okay, so we know that this one's going to be the next biggest. Okay, so that was C. Okay, then we know it's going to be A. Then we've got to decide between this one and this one, which really we know, because this number's bigger and it's the same base, that that's going to be the last. But if we wanted to check, it'd be about 3 to the 3.1. Yeah, about 3 to the 3.1. Okay, so we've got B, and then we've got D. So these can get really tricky, okay, on figuring out. All right, now just like anything to the 0 powers 1 rule, when we're dealing with fractions, we have those fraction rules, okay, which essentially tell us that it's a negative exponent. So x to what power is equal to 1 over x squared? Well, to make this a fraction, it's going to be x squared. To make it a fraction, it's negative 2. So that equals negative 2. 5 to the 1/5, or 5 to what power is equal to 1/5? Well, it's going to be negative 1. Okay. 2 to what power equals 1 over 8? Well, 8 is 2 cubed, so it's going to be a negative 3 to make the fraction. Okay, once again, no base, so we know it's log base 10. So 10 to the what power is 1 over 10,000. Okay, so 10,000 is 10 to the 4th, so I know it's going to be negative 4. And then x to what power is 1? Even though we don't know what x is, we do know it's 0. Now, we are going smallest to biggest, so we actually start with D, because negative 4 is the smallest, then C, then A, then B, then E. So in this case, the 0 is actually the biggest one here. All right, one more problem to look at. So we know this is log base 10, so 10 to what power equals 200. 10 to what power equals 0.02. 10 to what power equals, or 2 to what power equals 10. 2 to what power equals 1/10. And 2 to what power equals 200. Okay. Well, so the first one, to get to 200, 10 squared is 100, 10 cubed is 1,000. So it's going to be 10 to the 2.1 maybe. That's 125. 10 to the 2.2, 158. 10 to the 2.3 is 199.5. We'll call it good. So 2.3 would be our answer there. Okay, now 0.02, what does that look like as a fraction? It's really 1 over 50. So how can 10 become 50, and then it's just going to be a negative number? Okay? So, for 10 to become 50, it would be less than squared, right? So 10 to the 0.5 maybe? That's 3. Oh, 10 to the 1.5, that's what we need to try. Is 31. Okay. 10 to the 1.6, 39. 10 to the 1.7 is about 50. So this would be about negative 1.7. Okay, 2 to get to the 10th. Alright, so we know 2 squared, or 2 cubed is 8, and 2 to the 4th is 16. So 2 to the 3.5 would be 11. So 2 to the 3.4 is about 10.55. 2 to the 3.3, about 10. Let's maybe go 2 to the 3.35. I like that. So that would be positive 3.35. Now, on D, it's just the negative version, right? So negative 3.35. And finally, 2 to get up to 200. That's going to be quite a lot. 2 to the 5th is 32. To the 6th is 64. To the 7th is 128. And to the 8th is 256. So about 2 to the 7.5 is close. 2 to the 7.6 is really close. 2 to the 7.65 is about right. So it ends up being about 7.65. So smallest would be our D. Then we've got B. Then A, C, and E. And that's how we can use that inverse idea that logarithms and exponentials are inverses from each other to help us understand a little bit more about logs. And there we go.